Hi, in previous lecture I discussed MAX-HEAPIFY procedure. In today lecture I will discuss building a heap. We can build a heap by using MAX-HEAPIFY procedure in a bottom-up manner to convert an array. This is an array index starting from 1 till n, where n is array length, into a max heap. The elements in this sub-array a n divide 2 float function plus 1 till n. So this is the index or all leaf of the tree. I already discussed in previous lecture first half element at the internal node and last half element at the leaf. Suppose one array is given having 10 elements, then first 5 are internal node and last 5 are the leaf. So the procedure build max-heap goes through the remaining node, means first half node of the tree, and run max-heapify at each node. Let's discuss building max-heap algorithm. Array heap size equals to array length. For I, array length divide to float function down to 1. We'll call max-heapify procedure A of I. So this is all about build maxi procedure. We'll call build maxi procedure for I value half till 1. So we are calling n divide 2 time, and maxify running time is order of log n, that I already discussed in previous lecture. So total running time will be order of n divide 2 log n, or you can say order of n log n. We are calling build maxif for n divide 2 time, and each maxif run log n time. So total time is order of n log n. Let's discuss one example of building maxif. One array is given. This is the array, and first row are the index. Index 1 is the root. So 4 will be root, and first half means index 1 till index 5 are internal node, and index 6 till index 10 are the leaf. We'll call build maxi procedure starting from 5 till 1. So this is a array, and I will start from 5. As array length is 10, 10 divided 2 is 5. So initially I value is 5, and I value will decrease every time till 1. So I is 5. Now we'll call MAX-HEAPIFY procedure. We need to compare 16 with 7. 16 is the largest, so there will be no change. Next, I value will decrease. Now I value will be 4. We need to compare 2 with 14. 14 is the largest. Next, compare 8 with 14. 14 is the largest. So we'll swap 2 and 14. After swap, we got this. Next, I value will decrease. Now I value is 3. 3 have two children, 9 and 10. Just compare 3 with 9. 9 is the largest. Next, compare 10 with 9. 10 is the largest. Next, we need to swap 3 with 10. So after swap, 10 come here and 3 come here, and I value will decrease. Now I is 2. Now compare 1 with 14. 14 is largest. Next, compare 16 with 14. 16 is largest. So we'll swap 1 with 16. 16 will come here and 1 will come here. Next, we need to call MAX-HEAPIFY a 5. We need to call MAX-HEAPIFY a largest. Largest is 5. Now compare 1 with 7. 7 is largest, so we'll swap 1 with 7. Next, I value will decrease. Now I value is 1. Just compare 4 with 16. 16 is largest. Next, compare 10 with 16. Obviously 16 is largest, so we'll swap 4 and 16. 16 will come here and 4 will come here. Next, we need to compare 4 with 14. 14 is largest. Then compare 7 with 14. 14 is largest. So we'll swap these two. 4 will come here and 14 will go up. Now we need to compare 4 with 2. 2 is small. Next we need to compare 4 with 8. 8 is the largest. So we need to swap 4 and 8. So 8 will go off and 4 will come here. So this is a heap. Every parent value is larger than its children. So how to do BUILD-MAX-HEAP? One array will be given. First create the binary tree. Then call MAX-HEAPIFY procedure from n by 2 node till 1. Let's discuss a exercise. This was asked in Coleman book. Illustrate the operation of BUILD-MAX-HEAP on the array. One array is given. Now we need to illustrate the operation of BUILD-MAX-HEAP on this array. So first element is 5. 5 will be root. Its index will be 1. Then its child will be 3 and 17. So 3 index is 2, 17 index is 3. Next 10 and 84 will be child of 3. Next 19 and 6 will be child of 17. Next 22 and 9 will be child of 10. So this is a binary tree constructed from this array using level order. Next we need to do BUILD-MAX-HEAP procedure on this binary tree. So we'll call BUILD-MAX-HEAP array. Heap size is 9, total 9 element. Here last index is 9. Then for I, a dot length divide to floor function. 9 divide to floor function, that will be 4.5. Floor function is 4 down to 1. So first I value will be 4 and will decrease I value till 1. Next we will call MAX-HEAPIFY AI. Now compare 10 with 22. 22 is the largest. Next compare 9 with 22. So 22 is largest. We need to swap 10 and 22. 22 will come here and 10 will come here. After swap we got this. Next I value will decrease. Now I value will be 3. Now compare 17 with 19. 19 is the largest. Next compare 6 with 19. 19 is the largest. So we'll swap 17 and 19. 19 will go in index 3 and 17 will come in index 6. Next I value will decrease. I value will be 2. Now compare 3 with 22. 22 is largest. Next compare 84 with 22. 84 is the largest. So we'll swap 3 with 84. After swap we got this. Next I value will decrease. Now I value will be 1. So we need to call MAX-HEAPIFY index 1. Compare 5 with 84. Which one is the largest? 84 is the largest. Next compare 19 with 84. 84 is largest, so we'll swap 5 with 84. Here 84 will come and here 5. After swap we got this. Next again we need to call MAX-HEAPIFY index 2 as index 2 was the largest. So compare 5 with 22. 22 is largest. Next compare 3 with 22. 22 is largest. So we need to swap these two. 22 will come here, 5 will come here. Next again we need to call MAX-HEAPIFY index 4 as index 4 was the largest. So compare 5 with 10. 10 is the largest. Next compare 9 with 10. 10 is largest. So we need to swap 5 and 10. 10 will come here, 5 will come here. Finally we got the heap. Here every parent node is larger than its children. So first construct the binary tree from the array using level order. Next we need to call MAX-HEAPIFY procedure from n by 2 index till index 1. In today's lecture I discussed BUILD-MAX-HEAP with 2 examples. In next lecture I will discuss different approach of creating heap and insertion and deletion procedure. If this lecture is helpful for you, please like and subscribe. Thank you.